All right, thanks so much, everyone, for coming out. As you might have heard, there are 3 engineers here on the stage, so we are going to nerd out heavily, which is what I know you all came to talk about. No, I think we've had a lot of conversations over the last couple of days, and we're going to continue to have lots of conversations about increased load growth. Doesn't matter where the load growth is coming from, can be from electrification, data centers, and there are lots of great solutions. My office works on a ton of solutions of long-term transmission building, which we absolutely need to do. But then we also have to take advantage of our existing assets as much as possible in order to squeeze out every last bit. And both of you have been at the tip of the spear, really looking at different ways to do that, be it through, certainly through virtual power plants, and I think we'll talk about that in a lot more depth here, and taking advantage of the fact that there are so many new assets in terms of batteries that people have in their homes. Everyone I know seems to have a battery in their home. My father-in-law at Thanksgiving asked us to start pricing them out for everybody in the family so we can figure out where they go.
Good idea.
And so to me, I think about it as maximizing efficiency. That's my favorite term of art here. And I know that you're both thinking about that as well in order to make sure that you're not just utilizing everything properly from a nice engineering perspective, but really thinking about how that affects consumers along the way as well. So I'll pass it to you first, Rory, on what is New York thinking about moving forward? You're in this place where you have tons of growth happening. There's not as much space necessarily to continue to physically grow different parts of the grid. I'm from Massachusetts, so that is a common problem that we have here as well. But you're thinking creatively about how we can get through the next couple of years. And I think there's a lot that the folks here can learn from that.
So, clearly we have a lot going on in New York. And part of it is we need to build more generation, more assets, and we have plans and policies in place to do that, aligned with our overarching policy for a clean energy future and emissions-free resources. So those are all well underway through a variety of proceedings where we're either developing renewable energy or identifying the emissions-free technologies that are dispatchable that are going to help meet those periods where we need more energy and renewable isn't available. So all of that is happening right now. What's also happening is the other side of the conversation, which I think we're all here to talk about today, the virtual power plant, the harnessing the actions of individuals, consumers, businesses, residents, commercial entities, and seeing how we can make them a part of the health and well-being of the grid as a whole. And we talk about virtual power plants either using less energy or producing energy, but I'm thinking about this in the context of the state itself becoming a virtual power plant. Every single meter creates an opportunity for engagement with the consumer in a way that can help the grid manage the increasing intermittency from renewable energy and ultimately lower costs, not just at the individual level, but at the aggregate level, both for energy at the time it's being used, but also in terms of the need to build out the grid to be bigger, larger, and more robust. So all of these things are underway and part of our thinking in New York State. Much of this started by some of my predecessors, Audrey Zillman, through the Reforming the Energy Vision effort, which I think many of you are probably familiar with. But much of what we're doing today is a continuation of that and an expansion. And it's all enabled by cheaper technologies, better communication, and the availability of smart meters throughout the state. So I see a lot of potential for us to be able to manage the grid in these new ways.
Excellent. And I think, building off of that, I know, Patti, you had a very exciting announcement earlier today where I think you're trying to implement some of those very specific activities, especially around VPPs, with our friends over at EPRI through the Mercury Consortium. And we'd love to hear a little bit more about that.
Yeah, let's break some news here at Deploy24. Yeah, as we speak, over in the UK, an announcement is being made with EPRI and a company called Kraken. And Kraken's CEO, Omar Orad, is here in the audience somewhere. Kraken is working with EPRI to create a platform where we can have interoperability, much like Bluetooth back in the day became an open standard. We need that for electrically communicating devices. So whether it's heat pumps or thermostats or EVs, and all integrating to these smart meters and the distributed energy future, we need open, resourced interoperability. And so we're announcing a major consortium today, both in the UK and then here at Deploy24, about the potential for us to come together and create that open standard. So we're very excited about what that enables for a distributed, connected digital grid of the future.
So let's dig into that just briefly, because I think that open standardization is something that folks don't necessarily understand as well. And maybe if you just want to talk a little bit about what the benefits are, because sometimes we talk about standards as being overarching and more difficult to meet, but in this case, it's really opening up for more technology to enter.
Yeah, so compare it to Bluetooth for all of our devices. We can buy a headset from any manufacturer. I have a little portable speaker in my office that I like to connect to my phone. All of these Bluetooth-enabled devices in all parts of our lives are possible because there's an open Bluetooth standard. So similarly, in this way, we can have open standard interoperability of these digital electric devices. So imagine this, in fact, we had a situation like this. We had a new subdivision being built, and it was going to be an all-electric new subdivision of homes. If all of those devices can communicate to each other, we can use a lot less energy. So for example, uninterrupted, our distribution engineers and our building codes all required the entire panel for every residence and then the grid that supported it to be built for the maximum day with every device on it at full power, because we can't control it. And so you have to build for the peak plus 22%. Every house in that case was going to require a 400 amp panel. Well, we intervened and said, wait, if we have smart panels and we have wirelessly communicating electric devices that can manage what load comes on in an interoperable way, then all the panels actually became 200 amp panels. Those 200 amp panels reduced the peak energy demand for that entire subdivision by 50%. When you're building new, you've got to build smarter. And so having open standards like that would enable any appliance. In this case, you have to buy specialized appliances to make sure everything is interoperable. But when every appliance is enabled, when every device is enabled with an open standard, then every new construction project can be reduced in half, and any new retrofit can be enabled much more affordably. It's a huge opportunity for the industry and really for the world to decarbonize at a lower societal cost.
And that sounds so much easier than trying to convince my father to not do laundry at 6 p.m.
Amen.
In the middle of the winter on a Thursday. We've had that conversation many times.
I am sure you have.
And so I think interweaved with this conversation, right? Sometimes we talk about these all in a silo. We say VPPs are great, but I think talking about why VPPs are great in relationship to all of the other issues that we're facing, right? For both of you, you're looking at decarbonization, but you're also looking at significant load growth. And so by cutting that by 50% makes a huge difference. That's one less peaking plant that we might have to build. That's one less asset that we have on the grid that we have to figure out long term. And Rory, talk a little bit about what that means for consumers, because I think there's a lot of rate pressures happening at this moment in time as folks are seeing costs go up in a lot of different areas of their lives. They're very price sensitive when it comes to electricity.
Absolutely. And I mean, energy is the lifeblood of our society. So the more affordable we can make it, the more robust our economy can become. So we're always paying attention to the costs of any measure that we implement, and any measure we can implement that can cap or lower costs is something we aggressively try to pursue. So we look at VPPs. We have a program currently underway in New York, Bring Your Own Thermostat. Yeah. We have about 100 megawatts of load flexibility as a result of this program, where we simply manage the air conditioners of many homes, a couple 100,000 homes, plus minus 4 degrees. And that provides us with a lot of flexibility. And we're just at the very beginning of that. Imagine expanding that to include EVs and managing their charging. washing machines, washers, dryers, dishwashers, and other appliances in the home. So to the point you're making about the ability for this interoperability to happen, I think it's critically important for being able to integrate into the grid to give consumers the ability to manage their energy in a way where they can lower their costs and also help lower the costs for maintaining and operating and building out a bigger grid. And this is incredibly important. And I can speak to my own personal frustrations. During the pandemic, my fridge broke. I bought a new one. I had to download a very specific app to get that fridge to do demand response. Very different app than the app I had for my air conditioner, which was different from what I had for other appliances. So that created an ecosystem of trouble which didn't make sense for my family to engage in. And I do this for a living. So go figure. Now, if it's hard for me to do it, I can only imagine how difficult it is for the average consumer, which is why I'm so excited about what's going to be happening in the UK in the next few days.
Yeah, that automation, I think, is key for consumers, right? No one necessarily thinks about their electrical panel, my husband excluded, but and you want to make sure that they're not thinking about it all the time, but it can have such an enormous impact for the system as a whole. And I think that's what it comes back to is we can try and make consumers think about their electric use regularly, but it's just not going to happen unless you have an advanced degree in all this, like everybody sitting in this room from all the experience that we've had.
Maria, let me put a couple numbers to this.
Absolutely.
So in California, in PG&E service area, we have a summer peak of 20 gigawatts. Our winter peak is 10 gigawatts. And so today, uninterrupted, we have a load forecast that our demand is going to double. If we convert that to 40 gigawatts, that will be extraordinarily expensive. It's not just for the generation resources. Every conductor, every transformer, every pole, every substation is all designed for that peak demand. So today, what we're working on is making sure that we can double that load and at the same time only increase our peak by 13%. So 100% increase in base load, 13% increase in peak. And we're going to do that with a much more dynamic, intelligent grid management system. We've implemented a distributed energy resource management system at PG&E that will help us connect all these disconnected today devices and optimize their usage. You know, you talked about how we're all engineers. I'm an industrial engineer. This is like the era of this is our grand awakening. The industrial engineers get to reimagine the grid, that we can optimize supply and demand for the first time ever. Just think about the cost savings for customers, and it's savings in two ways. One, we're not building all that extra stuff, but two, we're fully utilizing the existing assets that we have. Therefore, the unit cost of energy goes down. There's a poster hanging in our offices back from the 30s and 40s, and it says, exciting news, PG&E is lowering prices again. I'm like, I want that poster back. Yeah. We're going to lower prices again because, just like we did back in the day, we had excess energy during the daytime. The electric grid was built originally for lighting. All of a sudden, we have all these power generation resources in the daytime that were underutilized. So what did we do? Electric streetcars, and then appliances, and then motors, and then rural electrification. We fully utilized that grid, and the entire time, unit cost of energy was going down. Rates were going down. We actually have the opportunity to go back in the future and do it again today. Because of data centers, because of EVs, which are the best of all because they're so dynamic and flexible, and electrification generally, we can decarbonize the economy and lower unit cost of electricity while we do it, as long as we don't just add to the peak. So the whole commitment to virtual power plants, the whole commitment to a dynamic digital energy grid is fundamental to actually enabling decarbonizing of the economy.
Amazing. That we could end right there, but we have 5 more minutes.
That's
and
right.
I would be remiss if I didn't ask, when you have a commissioner and a utility sitting here that aren't regulated and related to each other, what do you think that the other entity could continue to be doing to better enable more of this technology?
Well, I'll say this, the relationship is there and it's always going to be there. And we're going to have to work together with utilities throughout the state to achieve this goal. There's just no other way to do this. And so we want to engage, we want to be transparent, and we want equivalent transparency back. but it's going to require some degree of discomfort. We're doing things in a different way. But I think when you look at the history, to your point, you look at the history of the grid is not a static monolith. It's been changing every decade forever. And this next evolution is something I think we can do hand in hand with our utility partners as long as we get the incentives right up and down the value chain. We have to make sure consumers are in a position to take advantage of what we're doing, businesses, industry, et cetera. We need to ensure that we can work with the utilities to do planning proactively rather than reactively. Because to be frank, someone can go out and buy as many EVs as they want and connect them to the grid, but is the grid going to be capable of providing that service at that time? So we need to be able to look ahead and understand how do we change the plans that we've had in place for 20, 30, 40, 50 years and be prepared for this new future where people are going to be demanding things that the grid has not yet provided. So a lot of that is work that we have ongoing. We have dozens of proceedings, which I will spare you the burden of listing. But this is something the Commission is looking at constantly. And through these various proceedings, we establish a planning process through which we try to address these various issues and work with the utilities to find solutions ahead of their becoming a problem. Because at the end of the day, we want to be good economic regulators. We want to ensure that we are supporting the economic development of the state and not a hindrance through slow deployment of policy.
Yeah, so I would say ditto on, we have to work together, and I have infinite respect for my regulators. They have a very challenging job. There are a lot of voices. As we like to say, we regulate out loud in California. There's a lot that happens in a regulatory proceeding. And our CPUC works very hard to be fair and transparent and be that economic regulator. I think for all of us, having more visibility into the future and having courage to invest in the future, because if we're too late, we derail the electrification strategy. So we have to build it in advance. Now, the good news is there's more and more visibility to that demand and that new increased demand. So another plug for EPRI, the Electric Power Research Institute, we have a consortium called EVs to Scale. And EV to Scale includes the large fleet operators, it includes the utilities, it includes some commissioners. In fact, one of the Michigan commissioners is in the consortium and on the executive committee. And we need to have better forecasting of where that load is coming. And so the big fleet operators who want to put a distribution center and have an entire fleet of electric vehicles that can be 50 to 100 megawatts of new load can show up in a day are providing their forecasts and their plans so that our commissioners can have more confidence that the forecast is not just our forecast as the utility, but it is in fact the forecast of the customers. And so where more and more we can create transparency to those forecasts and do planning together, the better we can be prepared for that future and make sure that we're there when it comes. But I'll just give you an example of a case where Tesla wanted to put in a supercharger. They wanted 3.8 megawatts in one location for a supercharger, and my distribution engineers did their normal thing, and we told Tesla, you can have your supercharger in 4 years from now, which, as you might imagine, Tesla's not very patient, and they did not like that answer. But the reality was my distribution engineers only had a tool that said, what is peak plus 18%? And if you can't serve that, you can't serve it. Well, when we gave them new tools where they could see which hours of which days can they serve 3.8 megawatts, 360 days a year we could serve 3.8 megawatts with no incremental investment. So we could enable that new load, but then on those 5 days, our new DERMS, Distributed Energy Resource Management System, actually has control. So the grid operators don't have to worry that we have to count on someone to take action. We actually can control that load on those days, and in 4 years, they can have 3.8 megawatts whenever they want it, but for now, they can still add that new demand to the grid and serve electric vehicles. So the digital tools that enable virtual power plants, that enable digital optimization and management of the grid so that we can both have reliable energy but lower cost energy, those tools and equipment and technology is now available and commercially accessible so we can actually do these things that we've been dreaming about for years and years.
So that's a perfect way to end, to say that we're really grateful to all of you that have applied for GRIP Awards here out of the Grid Deployment Office, many of you who are working very closely with both your regulators and your utilities, and I hope that you continue to do that moving forward, because I think the partnership aspect is so important. So I want to thank these two visionary leaders who are just amazing creative thinkers for being here with us today to share some of their insights on the future of the grid, and in particular, how they're thinking about using our existing assets. So thank you so much for being here, and appreciate your time.
Thank you, Maria.
Thank you.
Thanks, Rory.